is Alton Smith. I'm going to do a short video on Slayer Exciter today, something I started fooling with about a month and a half ago. I bought a kit from Teslatronics and one from G Bluer and got fooling around with this stuff a little bit. I normally make Tesla coils. I don't normally do this kind of stuff, but I sort of got a sparked interest in it, and I don't believe in free energy or all that other stuff, but I do believe in pure science, and I like to understand how things work. So I actually bought the kits, played with them for a while, seen what I could do, but then I sort of lost interest in it. It's hard to say this, but when you're used to making sparks go 2 foot to 5 foot, lighting light bulb sort of loses your interest real fast like. But that being said, I also believe in pure science, which is understanding how wireless energy works. And I was actually working on this Tesla coil the other day, and I got to actually looking at a circuit that G Bluer I had here from G Bluer. And I was looking at the coil itself, and I got to thinking maybe I was approaching what I wanted to do the wrong way. I actually wanted to see pure plasma flow come from one of these things at a high rate. So I sat down and started trying to design a circuit that would allow plasma flow energy to a great degree. In fact, I blowed 62 transistors in 2 days trying to do this thing, trying to keep one alive. Because anything past about 20 volts an amp of current, I was popping transistors left and right. Couldn't keep them going, wouldn't take the stress load. I finally got one down pat and created a circuit where I can keep it alive. I can run it 30 minutes at 40 volts with no problem now, and I can get 6-inch plasma flows from it with no real problem. To be in fact, I will show you what I mean here. That's plasma flow off of one of these. It's 6 inches away. Actually, I'm probably 8 inches away. Get us closer and it just goes stark raving crazy here. It took me a while to figure out how to design this circuit to keep from blowing the transistor, because it would fry this thing after it took a few seconds of doing this. It would just kill it. But I finally got the circuit created to where I can do this I've run it for 30 minutes at 40 volts with no problem. The actual circuit does not get near hot, but I do run a fan on it, because once you leave it on for 30 minutes, it does have a tendency to warm up to about 130 degrees. The metal heat sinks do not work good on this. Aluminum heat sinks work much better. You also need a ball on this thing to work this circuit good. Tried an 8-inch ball and a 10-inch ball. The 6-inch ball actually performed better than any of them did. The circuit consists of just a transistor and 2 resistors, which I'll show you the design of it in a minute. It does put out a lot of energy. In fact, I'm not sure just how hard I can push this thing. I know it'll do 40 volts. I've got a 60 volt power supply ordered. I can't get much past 60 without paying $500 or $600 for power supply, and I'm not going to pay that for one. But it's an amazing amount of energy I can get. I can take a piece of metal 6 inches away and get plasma flow just like this to the metal, but it's hard to see with the lights on. The circuit itself is an easy design circuit. In fact, I had a friend, Michael Judd. This is actually a circuit that he used right here, very similar to it. And I'm not sure how good you can see this or not. The circuit is a TIP31C transistor. It has 2 resistors in it, and that is the limit of what's in this circuit. I have run it at 40 volts with no problem. You can run it down to 12 volts and get plasma flow out of it the way it is right now. Actually, like I said, I run a small fan on it, but with the fan you got to use a 150 ohm resistor on the positive side of the fan, because at 30 volts you'll fry the fan pretty easy with no problems. I'm not really into free energy, but this is, I guess I wanted to see if I could ever get an arc out of one of these things using a regular transistor. I wanted to see free flowing plasma, and I'm going to play with it till I can finally try to get free flowing plasma. I would actually like to be able to see it leave the ball with no problem like this, but go to a metal object like a Tesla coil would do. Not sure if I can get it there. The design of these circuits are a little harder to make like that, but I'm getting tremendous amounts of energy out of this thing. My coil is 15 inches tall right there. It's number 27 gauge wire, 3.5 inches in diameter. The primary is 9 turns of number 14 stranded wrapped wire. It works good, but be forewarned right now. This thing will burn you bad. Everything within a 7-foot area that's bare metal is hot and it will burn you. I mean, I've gotten burnt bad 2 or 3 times already not watching what I'm doing. It puts out a lot of energy out here for about what you're seeing here to doing this. And it will definitely, you'll have to get over being burned with it because it'll do it to you real quick like. But the amount of energy, I don't know how much I can get out of this. I know at 50 volts, you should run with no problem because I can run this like this and turn it off and put my hand on the transistor and it's not hardly that hot. And hot enough I can just put my hand up and keep it there. And I could power it up at a full 30 volts. Before I got the circuit designed the way it was, I used to have to power it up at about 15 and bring it up or it popped the transistor. This thing puts out a lot of energy. I question how far I can really push it. I don't know. I normally make Tesla coils. I don't generally fool with this type of stuff, but I find this interesting to a degree. I wanted to learn a little bit more about it. If you have any comments, please send them to me. If you, any, good points, bad points, whatever, I'm open. This is actually my email address if you want to email me directly. It's w5als@yahoo.com. The other one is actually my website, antiqueradiotubes.com. I sell antique radio tubes to fund all this with. I'm welcome anybody to email me. I will try to explain what I'm doing the best I can. I've been fooling with electronics for about 35 years now. I had a radio and TV repair shop for 30 years. I won't say I know everything, but I do have a great deal of understanding of electronics. If you do email me and it gets into a lengthy email, be forewarned. I had a bad wreck 3 years ago and my left hand and my right leg is numb. Typing on the computer hurts me a lot. So if it gets into a long, lengthy conversation, it would be better over the phone, and I don't mind calling somebody, talking to them, because I can't type for a long period of time. But that would be up to the individual. But the amount of energy I get out of the circuit, it's enormously great. My thing is, my next thing I'm fixing to do, I'm changing the circuit. I want to see what it's going to do. This is the one I'm working on at present. Right here. I'm going to make this into that this coming week hopefully and try it with a bigger coil and a bigger top to see how good it works. I don't know exactly how much better it's going to work than this. This one's absolutely the best. It works better with a 6-inch ball than it does any other size ball. I tried it with a 4, 6, 8, and a 10. The 6 by far did better than anything, and you can buy these 6-inch balls for about $10 online. If you go look for them, you can find them. But it works real good. Just if you make it, be careful. It will burn the mess out of you, I promise you. I do hope you enjoyed the video. One last time I will show what the plasma does again. I hope this does show up on the video to be in fact, that's 12 volts right there and it still has plasma flow out of it. That's 20 volts, that's 30 volts. I mean, it gets a lot of energy